Right, where we left off in the last segment, we were about to do a conversion between 5.3 kilometers and inches. How many inches are there in 5.3 kilometers? There are several different ways that you can do this, and maybe we'll see all three, or well, several of them, just to illustrate that there are different ways of doing these calculations. But the one that occurred to me first was using the definition of the metric prefixes to go directly from meter or kilometers to meters. Then we can go to centimeters, and then we can go to inches using conversion factors that that we know either from the metric system, the meanings of the metric prefixes, or the conversion between inches and centimeters that we just saw. So if we have 5.3 kilometers, and that's effectively over 1, and we want to end up with inches, also effectively over 1, we have to get rid of kilometers in favor of a new unit for basically each step of the way. And then each step of the way, you get rid of the unit that you introduced in the previous step, and you introduce a new unit. So if we're going to go from kilometers to meters, we know that kilo means 1,000, and we know, so that means there's 1 kilometer for every 1,000 meters. Oh, sorry. Kilometers, kilo means 1,000. So 5.3 kilometers means 5.3 thousand meters, which you can get by multiplying 5.3 times 1,000. So notice kilometers or kilometers is on the bottom here, and it's on the top here, so that will cancel out. And if you take 5.3 times 1,000, you will have the number of meters in 5.3 kilometers. And you could stop and you could write that down, and then you could go on to the next step down below if you want to. To save space and a little bit of time, I'm going to go on to the next step. So now we've got our number of meters. We want to move on to centimeters. Centi means 1/100th of something. So there's 1 centimeter for every 0.01 meters. Or there are 100 centimeters in a meter. So you could write this as either 100 centimeters over 1 meter, or 1 meter over 0.01 meters. Sorry, 1 centimeter over 0.01 meters. Mathematically, it comes out the same either way. I wrote it this way because this way conforms more exactly to the definition of what centi means. It means 1/100th. Again, you can tell where the units need to go though, because meters is on the top here, but we don't want meters in our answer. We want inches, so we have to get rid of meters in favor of something else. So meters is on the top here. That means it has to go on the bottom in the conversion factor. So 1 centimeter is 1/100th of a meter, or you could write 10 to the minus 2 in the denominator, or 0.01. So now meters cancel, and we can stop and write down the number of centimeters here and go on to inches in the next step, or we can just keep going. Okay, we just saw that there's 2.54 centimeters for each inch, as we just saw in the last example. We want inches as the answer, so that's where that's going to go in the conversion factor, and we want to get rid of centimeters, which is in the top here, so it has to go on the bottom here. There's 1 inch for every 2.54 centimeters. Okay, so centimeters will cancel, and we should end up with inches. Mathematically, all you have to do for your calculator is take 5.3 times 1,000 divided by 0.01 divided by 2.54. The ones you can just ignore. Whether the one, excuse me just a moment. All right, now that we're back from that rude interruption, we'll pick up where we left off. You can ignore the ones when you're putting the numbers in your calculator, regardless of whether the one is on the bottom or on the top. You just basically deal with the numbers that are not ones. And if they're on the top, you multiply them. If they're on the bottom, you divide by them. So that your calculator doesn't misunderstand, it would probably be a good idea to hit equals after each step, especially when dividing by a number. So if we take 5.3 times 1,000 equals 5,300, divided by 0.01, which equals 530,000, divided by 2.54. And that's 208,661.4173. That's what my calculator tells me. Obviously, that is a completely ridiculous number of significant figures. We're going to want to adjust that a bit. Looking back at the numbers that we have here, 5.3, that's only two significant figures. 1,000 meters per kilometer, though, that is a definition within the metric system, so that's infinite. 1 centimeter for every 1/100th of a meter, that is also a definition within the metric system, so that's infinite. Inches to centimeters, though, that's between English and metric systems, so that would be 3 significant figures. So it looks like 2 is all we're limited, or all we're able to have here. So the 2 and the 0 can stay, but everything else has to go. The first number we're dropping, or the first digit we're dropping, is an 8, which means the digit before it has to go up by 1. So the 0 becomes a 1. And then we have 4 more digits before the decimal point. So then we have to fill in 4 zeros. Don't actually write the decimal point in, though, because this, as this number is written, is 2 significant figures, the 2 and the 1. Remember, zeros at the end of a number do not count if there's no decimal point. If we put the decimal point in, now this is 1, 2, 3, 4, 5, 6 significant figures. Way too many. So don't put the decimal point in. So 210,000 inches, or you could put it in scientific notation if you want. We have to move the decimal in order to get the first part of the number to be between 1 and 10. In other words, 210,000 is going to become 2.1 times 10 to something. We have to move the decimal point from where it is at the end of the number 1, 2, 3, 4, 5 places to the left. And this is a large number, so it's going to be a positive exponent. So we could give this as 21,000 inches with no decimal point, or 2.1 times 10 to the 5th inches. With numbers like this, scientific notation is actually preferable because it leaves no doubt as to how many significant figures there are supposed to be. This number here, we tend to assume that it's 2 significant figures because we tend to assume the worst case scenario, but it could be 3 significant, it could be 4, it could be 5, could be 6, depending on how accurately you measured it. Scientific notation leaves basically no doubt as to how many significant figures there are. On the other hand, if I don't specify what form the answer should be written in, you're free to leave it in the decimal form if you want to. Another way that we might be able to do it that involves fewer steps would be if we look at that conversion factor sheet and find out how many inches there are in a meter. So we could go kilometers to meters to inches. The kilometers to meters is the same as it was up above. It's just the next step that differs. And if we look back at the conversion factor sheet between meters and inches, there we go. 1 meter is 39 point, actually it's 39.37. I'm going to use 39 point, I'll use 39.4 because that's what's on the list. I always remember it as 39.37. And we want meters on the bottom, and we want inches on top. So we'll call it 39.4 inches per meter. Meters cancel with meters, and we have inches. If we have 5.3 times 1,000 times 39.4, we get 208,820. And you might look at that and say, wait a minute, 208,820 is different from 208,661.4173. And it is, but the real question is, do we really know the number that accurately so that we can say that it's different from this? And in order to answer that question, again, we have to go back and look at significant figures. 5.3 is only two significant figures. 1,000 meters per kilometer is infinite. 39.4 inches per meter is 3. So two significant figures is all we're allowed here. So again, the 2 and the 0 can stay. Everything from the first 8 onward has to go. Since the first digit we're dropping is an 8, that means the 0 has to become a 1. And look what happens. We end up with 210,000 inches again, just like we did before. Or 2.1 times 10 to the 5th. So to the number of significant figures, we actually know this number. It is exactly the same as what we got before. It's just all those extra digits, those were an illusion. We don't really know those. All right. So that's an example of a couple different ways that you can do a conversion. There are actually numerous other ways that you can do that conversion too. You can do, let's see, say if you want to convert 375 milliliters to gallons. So what we've got here are volume units, milliliters and gallons. And let's see, we can go to, we might want to have a look at the conversion factor sheet here under volume, since milliliters and gallons are both volume measurements. Let's see, we have the relationship between liters and quarts. That's the first thing here. So if we can get from milliliters to liters, we can get to quarts, and then we can get to gallons. So that's one possibility. We could try that. A lot of times when you have multiple step conversions, especially if it's between the English and metric system, sometimes it helps if you, to lay out the steps, it can help to sort of think ahead, how am I going to get from the English to the metric system in this type of unit? So like that's basically what we did here by looking at the volume units. Liter is metric, quarts is English. We've got a conversion factor right there between metric and English. So if we can get from where we started to liters, we can use this conversion factor to get the quarts, and then we can go from quarts to gallons. And so this is kind of like the midpoint that we're shooting for. We got to get the liters, then we can get the quarts using this, then we can get the gallons. So if we have 375 milliliters, and that, again, you can think of that as being in the numerator. And now we have to go to liters. We know that milli means 1/1000th. So there's 1 milliliter for every 1/1000th or 0.001 or 10 to the minus 3 liters. You could also write this as 1 liter over 1,000 milliliters, and mathematically it would come out the same. It's just I'm doing it this way because this, again, conforms to the definition of what milli means, 1/1000th. So at this point, milliliters would cancel, and we end up with liters. And again, you can write down the answer and then use that answer as the starting point for the next step if you want to, or you can just keep going, understanding that we now have liters. We can go to quarts using that conversion factor that we just saw on the sheet. We know we want liters on the bottom and the new unit on top. And it's 1 liter for every 1.057 quarts. Okay, so in other words, 1.057 quarts for every 1 liter. Liters will now cancel, and we have quarts. And they don't have conversion factors from one English unit to another on this conversion factor sheet because nobody really cares about English units that much in science anymore. But hopefully you'll remember that the reason a quart is called a quart is that it is a quart is a quarter gallon. So in other words, there are 1 gallon is 4 quarts. And now quarts in the numerator will cancel with quarts in the denominator. And we get 375 times 0.001 equals 0.375 times 1.057 equals 0.396375 divided by 4 equals 0.0990937. Okay, so that is our number of gallons so far. That is obviously way too many significant figures for the numbers that we were using here. In terms of significant figures, looking back, 375, that's 3. 1/1000th of a liter per milliliter, that is a definition within the metric system, so that's infinite. 1.057 quarts per liter is between English and metric units though, so that is not infinite. That is 1, 2, 3, 4 significant figures. And 1 gallon for every 4 quarts, that is a definition within the English system, so that would be considered infinite also. So it's between 3 significant figures and 4, so 3 is what we're limited to. And keep in mind also that the 0 at the beginning of a number does not count as a significant figure, so that can stay. And in addition to that, 3 more digits can stay. So the 9 and the 9 in the 0 can stay. But everything from the next 9 on has to go. Since the first digit we're dropping is a 9, the digit before it has to go up by 1. So this is 0.0991 gallons. Okay, and that would be to the correct number of significant figures. 3 significant figures, because again, or you can also write it if you want, is 0.0991. The zeros at the beginning, though, don't count. So that's 3 significant figures. Note also what we said about if the unit gets bigger, the number should get smaller. If the unit gets smaller, the number should get bigger. Gallons are quite a bit bigger than milliliters. A milliliter is about the size of a sugar cube, about like a box, 1 centimeter on each side. And a gallon is, big. So the units got bigger, the number should get smaller. The number went from 375 to 0.0991. So yep, the unit got bigger and the number got smaller. So that's a good sign. We can look at some conversions within the metric system also. That's something that we should definitely pay some attention to. Okay, so we know hopefully what the prefixes mean numerically in the metric system. But so far we've been faced with cases where we just have to convert from, say, a unit with a prefix to a unit that doesn't have a prefix, or maybe the other way around. It can get a little bit more complicated though if you have to convert a metric unit with a prefix to another metric unit with a prefix, like for instance centimeters to kilometers or kilometers. What I would do in that case is go to the base, stop off at the base unit along the way. So in other words, if you're going from centimeters to kilometers, go from centimeters to meters, and then to kilometers. Don't try to go directly from centimeters to kilometers. For one thing, metric conversions are not on this sheet. They just rely on you to know what the prefixes mean. Trying to combine the values of two prefixes at the same time is really too much to try when you're first still getting used to this kind of stuff. So I would not try that. I would go from centimeters to meters and then meters to kilometers. Now you could do it in 2 steps or you could do it all at once. That's up to you. But I definitely wouldn't try to go directly from centimeters to kilometers all in one go. Okay, so we have 356.4 centimeters, and you can think of that as being in the numerator with just a 1 on the bottom. And in the first step, we need to go to meters. So that means we want centimeters to be in the denominator, and we want meters to be in the numerator. And now you could look at the definition of centi, meaning there's 1 centimeter for every 1/100th or 0.01 meter. Or you could also write that as 1 meter over 100 centimeters, and it would work out the same way. Anyway, at this point, this means that centimeters are going to cancel, and we will end up with meters as the unit at this point if we stop and write down the answer. But we want kilometers, so that's going to be the next step. If we want to get rid of meters and end up with kilometers as our unit, that means kilometers has to be in the numerator and meters has to be in the denominator. And there's 1 kilometer for every 1,000 meters. That's what kilo means, 1,000 or 10 to the 3rd power. And so meters now should cancel, and we will end up with kilometers. So we have 356.4 times 0.01 equals 3.564 divided by 1,000, which is 0.003564 kilometers. That's a really small number, which is expected because the unit got bigger, got quite a bit bigger. You know, a centimeter is only about the width of the tip of your little finger. A kilometer is a little over half a mile. So the unit got a lot bigger. It's not surprising that the number got a lot smaller. It definitely should. For significant figures, let's see, 356.4, that's 4 significant figures. The conversion factors are both within the metric system, metric to metric. So those are both considered infinite significant figures. And so 4 it is. And it looks like we've got 1, 2, 3, 4 significant figures in the answer. So for once, the calculator gave us the right answer to the right number of significant figures. So 0.003564 or 3.564 times 10 to the minus 3, because in order to get this number to be between 1 and 10, you have to move the decimal point 1, 2, 3 spaces to the right. And it's going to be minus 3 because the original number was less than 1. So minus 3, not plus 3 for the exponent. So either of those would be perfectly okay. Let's see, we can go say pounds to grams, or so let's say let's make it more interesting. Convert 35 nanograms to pounds. This is units of mass, which we haven't used before. So if we look at units of mass here, we've got the relations between pounds and grams. and kilograms and pounds. So what have we got here? We've got nanograms to pounds. So let's see if we can get from nanograms to grams. Where is it? Mass. If we can get from nanograms to grams, we can get the pounds. So that's the way we would probably want to do it. Go from nanograms to grams to pounds. So if we have 35 nanograms, and we want to go to grams, so grams need to be in the numerator and nanograms need to be in the denominator. And there's 1 nanogram. The definition of nano is 1 billionth or 1 × 10⁻⁹ of, or sorry, 1 × 10⁻⁹ of a gram. And I'm going to use the exponent form in this one. I'm not going to write 0.8 zeros and then a 1. And so then nanograms will cancel and we have grams as our unit. If we then go to this conversion factor here, where is it? Mass. Okay, there it is. 453.6 grams would be 1 pound. We want grams on the bottom, so it'll cancel out with grams on the top here. And then we want pounds because that is the unit. Okay, so there's 1 pound for every 453.6 grams. All right. Raising a number to a power on a calculator is something that you may not have done if you haven't taken math classes that do that kind of thing, or if you haven't taken science class before, or even if you have, you might be getting used to a new scientific calculator. So I'll show you how to do that when we get to it. But for this answer, all you really have to do is take 35 times 10⁻⁹ divided by 453.6. So we take 35 times 10. And the way you raise 10 to a power is with the little up arrow or caret button here. Raised to the power of -9. When you're making a number negative, you use the minus sign that's down here at the bottom, not the minus sign that's for the operation of subtraction. So this one here is subtraction. This one is making a number negative. Okay, and that equals this number. And it should be really small because 35 times 10⁻⁹ is going to be 3.5 times 10⁻⁸. So there should be 7 zeros in front of the 3, between the decimal point and the 3, that is. So 1, 2, 3, 4, 5, 6, 7, right? And then we divide by 453.6, divided by 453.6. And we get this, 7.7160493383 times 10. And notice the times 10 to the -11 is sort of tucked away here at the end. So whenever you do a calculation in this class, because we use a lot of numbers that are very big or very small, a lot of times there will be the little times 10 raised to a power at the end. You have to make sure that you look for that so that you don't miss it. So it's this times 10 to the -11 power. And that's the number of pounds. Obviously, this is way, way too many significant figures. Looking back at the numbers that we had in the problem, we started with 35. That's only 2 significant figures. Okay, so 2. 1 and 10, the relationship of 1 to 10 to the -9, that is a definition between metric units. So that is infinite. That's a very badly drawn infinity sign. And 1 pound for every 453.6 grams, that is between English and metric units. So that is not infinite. That's 4 significant figures. And so 2 is the limit. So this is going to have to be 7.7. And then you drop everything from the 1 on. Since the first number we're dropping is less than 5, the numbers before it can remain the same. And so that becomes 7.7 times 10 to the minus 11 pounds. And that is your final answer to the correct number of significant figures. Okay. Well, having shown that, I see that we're way over time on this video too. So I'm going to have to cut this off here and maybe make the next one a little shorter, hopefully.